Understanding multipath. Here, we're going to try and visualize what RF looks like as if you could see it through an RF eye. We have a scene here made up of a few mountains, an aircraft flying by, and several transmitters across the landscape, and we want to visualize what they would look like in the RF domain. Obviously, we can't see RF, as the human eye can only see visible light, which is within a few hundred nanometers, whereas RF is much lower frequency, measured in a few millimeters, centimeters, or meters. Ultimately, what we want to try and get across here is how RF energy reflects. Reflects across the ground cover, and buildings, so you can see some of the challenges that an RF detection system, DF system, or geolocation system needs to cope with to be able to deal with those reflections and the interference which comes from those reflections. But primarily today, we're looking at how RF energy reflects off the landscape and objects. Okay, so the second scene we have is showing two RF sources. Firstly, an aircraft which is emitting at a certain frequency. We've colored that purple. And as the aircraft flies by, we can see its RF energy illuminates and reflects off the ground. It's either scanning the ground or we're seeing a side lobe from an onboard directional transmitter. But ultimately, spillage from whatever the transmission is illuminates the ground and the objects around it. What we see here is what we would see if you could have a very, very high precision, high resolution RF sensitive eye. Secondly, in this scene, we see a radar. We see the pulse as it rotates and sweeps across, illuminating the landscape. And as it looks straight at us, you can see we're getting specular reflections from the buildings and landscape as we're sweeping by. As a system trying to look for the source and geolocate it, we're seeing energy direct from the radar and reflected away from it, which ultimately gives us some ambiguity in understanding where that RF energy is coming from. What we will see, though, is that the power level from the radar as it passes us will be much higher than the reflection back from the building or mountain. It is this peak energy difference that we use to isolate the signal source and give us an accurate line of bearing. There is a caveat to the RFI we're seeing here, with such a high-resolution image. It's suggesting that we're using a system which is far higher resolution than is possible. In reality, it would have to be an impossibly large scanned phased array to get anywhere near the resolution we show here. So we have to pixelate the view, and as we continue pixelating, we see we have less resolution down to, say, 3 pixels, which nicely represents the face of an RFI array direction finding system. The size of the antenna system used is really defined by the wavelengths we're looking at here. So, we can see as the aircraft and radar sweep across the landscape, the 3 directional antennas pick up different amounts of energy. And because they are directional, we can calculate to within a couple of degrees the exact position of the transmitter. So, what we're trying to get across here is the multipath effect. If you look with a human eye, you obviously can't see RF, and you can't see the reflections created. By creating a visual reference like this, it should be easier to judge what happens in the real world. There are 2 aspects of multipath. One where we can pick up the illumination and potentially see that as an ambiguous target or transmission location, and secondly, we have the effect of the multipath in the form of interference patterns, which are ultimately received at the RFI system as it tries to resolve what's within the field of view. So, the key part of this view is that we see reflections off the ground, and we see reflections off objects, yet the transmitter is just seen as a point source. Another interesting visual reference here is that RF is not really affected by specular diffraction, as you might see with a light bulb emitting photons on a foggy day. If, for example, we were looking at certain microwave frequencies through rain, you would see a similar effect to this. In our next video, we'll look at TDOA and how multiple omnidirectional antennae can be used to geolocate a number of static and moving transmissions and see what effect multipath has on that. Thanks for watching. And don't forget to visit crfs.com for more RF insights and technologies to detect, identify, and geolocate signals in complex spectrum environments.